Almost every musician has had the experience of hearing a song and wanting to know how to play it. My project is part of a larger work that will use a neural network to provide a score from an audio file. I have been working on the data collection, analysis, and processing step of this project. The data that I collected is a set of paired audio and MIDI files. I then analyzed the dataset to gain insight into its creation as well as some statistics about it. Finally, the dataset was processed and manipulated into a format that could easily be used to train a neural network. The dataset used in this project is the Maestro dataset. This dataset contains over 200 hours of data, with songs ranging from 45 seconds to 43 minutes. The mean song length is about 10 minutes, and there is a standard deviation of lengths in this dataset of about 7 minutes. Here is a histogram visualizing the stats that I mentioned earlier. As you can see, the majority of songs are between 2 and 16 minutes. The Maestro dataset was collected from over 10 years of performances at the International Piano E-competition. Playing in the background is Prelude and Fugue in G major by Bach from the 2008 competition. This is the song that will be represented in the rest of this presentation. In this competition, performers play on a Yamaha Disklavier piano, which records precise MIDI information. At this point, you may be wondering what the actual difference is between MIDI and audio files. The best way to describe it is that an audio file records sound and a MIDI file records activity. As shown in these two images of the same 5 seconds of the song, the audio shows the sound waves produced, whereas the MIDI shows which keys of a piano were pressed, how hard they were pressed, and how long they were held. Here are 3 different ways to represent a G major 7 chord to a C major chord. The first is with a score. This score says, play the G chord for half a second, and then play the C chord for half a second. The piano keys to the right show how to play those chords on a piano. The bottom shows a time series, which is a transformation of a MIDI file, split into rows of 64 milliseconds, where each MIDI note is a column. A 1 means the note is being played at the corresponding time. The last piece of processing was to split the songs into manageable chunks for a neural network. These chunks can be inputted as if they were separate songs, and then the output can be put back together to recreate the whole song. The top of this image becomes our input and the bottom our output. So why did we decide on transforming the MIDI files into a time series representation? The main reason has to do with the structure of a neural network. At a very basic level, neural networks have input and output, usually in the form of nodes. By using a time series, we can input audio and output binary that corresponds to the keys of a piano. For example, if we put in a single note, the tuning note A440, we would expect only MIDI note 69 to light up and the rest to be dark. In the future, I plan to use this data to train a neural network and eventually turn the MIDI files into a musical score. This would allow a score to be generated from audio of any piano music. Thank you.